Lying is a captivating phenomenon. It's a complex dance between truth and fabrication. Our brains become stages for this intricate performance. A symphony of neurological processes is set in motion. Understanding this orchestra can be enlightening. It offers a glimpse into the deceptive heart of humanity. At the forefront of this cosmic deception is the prefrontal cortex, our brain's executive control center. Responsible for planning and decision-making, it faces a challenging task during a lie. It must suppress the truth while constructing a believable fabrication. This balancing act strains the prefrontal cortex. Think of it as a conductor leading a symphony. Truth is a harmonious tune. Lying is a complex composition. It requires more focus and effort. The prefrontal cortex ensures the lie is convincing. This increased workload on the prefrontal cortex translates into a higher cognitive cost for lying compared to truth-telling. Studies using brain imaging techniques like fMRI have shown increased activity in the prefrontal cortex during acts of deception. This heightened activity suggests that lying requires more cognitive resources, demanding more energy from the brain. Imagine our brain as a vast and intricate computer network. Truth-telling is like running a simple program, requiring minimal processing power. Lying, however, is akin to launching a complex simulation, demanding significantly more energy and computational resources. This energy expenditure can manifest as cognitive fatigue, making it harder to maintain the facade of deception. Intriguingly, research suggests that individuals who lie habitually, known as pathological liars, exhibit structural differences in their brains. Studies have found that pathological liars tend to have more white matter in their prefrontal cortex. White matter is responsible for communication between different brain regions, and this increase might contribute to their enhanced ability to fabricate and manipulate information. Imagine a vast network of roads connecting different cities. In the brains of pathological liars, these roads, representing white matter, are wider and more extensive. This allows for faster and more efficient communication between different brain regions, potentially facilitating their ability to construct and maintain elaborate lies. Section 5. Amygdala's alarm, red alert in the cosmos of deception. The amygdala, deep within the brain, processes emotions like fear and anxiety. When we lie, it triggers a stress response. This can cause increased heart rate and sweating. The amygdala acts like a cosmic alarm system. Lying triggers this alarm, preparing the body for fight or flight. This heightened state can be detected through physiological measurements. Section 6. Frequent liars, a diminished signal amidst the noise. However, frequent liars often exhibit a diminished response in the amygdala over time. This suggests that their brains may become desensitized to the emotional and physiological consequences of lying. This reduced amygdala activity might allow them to lie more convincingly, as they experience less stress and anxiety associated with the act. Imagine the amygdala's alarm system becoming less sensitive over time, like a smoke detector with a dying battery. As someone lies more frequently, the alarm signal weakens, and their physiological responses become less pronounced. This desensitization may contribute to the apparent ease with which habitual liars can deceive others. Section 7. The dopamine delight, a rewarding constellation of lies. Further complicating this cosmic dance of deception is the brain's reward system. When a lie is successful, the brain releases dopamine, a neurotransmitter associated with pleasure and reinforcement. This dopamine rush can create a positive feedback loop, reinforcing the act of lying and making it more likely to occur again in the future. Imagine the brain's reward system as a vast network of stars, each representing a potential source of pleasure. When a lie proves successful, a cluster of these stars ignites, flooding the brain with dopamine. This celestial fireworks display reinforces the behavior, making future lies more enticing. Section 8. Unveiling deception, practical applications across the universe. Understanding the neuroscience of dishonesty has far-reaching implications. In legal settings, insights into how the brain processes deception can help improve lie detection techniques and evaluate the credibility of testimonies. Security agencies can leverage this knowledge to develop more effective methods for identifying potential threats. Even in our daily lives, understanding the subtle cues and physiological responses associated with lying can enhance our ability to detect deception in personal and professional interactions. By unraveling the mysteries of the dishonest brain, we gain valuable tools for navigating a world where truth and fabrication constantly intertwine.